Hello everyone, my name is Josué. I'm a technician, professor and doctor, and today we are going to talk about electrical installation in explosive atmosphere. Specifically today we are going to talk about the part 1 of 4 hazardous areas classification concepts. But why know that really? Well, the first thing that comes in mind is when we have a hazardous area classification, we have the certification process, and in the certification process, we have a lot of things to cover, and one of that is the group of each explosive substance. To do electrical installation in an explosive atmosphere, we have to have certified equipment, and because of that, we have to understand each of this code here that we will do in the end of the 4 class. And the first thing that comes in mind regarding the explosive atmosphere is that we have different substances. We have gases, we have vapors like diesel, gasoline, we have dust and fibers like wood, sugar, cough powder. They behave differently. They are chemically and physically different in ways that we have to understand in different places. That's why hazardous area classification. And of course, when we install electrical equipment in these places, we have to have different measures, different installation, different constructions. We are going to talk about in the next class. Today we are going to talk about the hazardous area classification process. The first thing that we have to understand is that to identify this place, to classify the hazard and design the equipment, there is some standards. The first standard that we have is the IEC. How to understand, how to classify, how to monitor it, and other things regarding hazardous area classification. Also, we have the API, where we have some guiding figures that help us to do the hazardous area classification. But how exactly can we identify a hazardous area classification? Well, one of the first things that we have to understand that we have to have 3 things happening in that area. The presence of a fugitive emission, the presence of a flammable mixture, and a process equipment continuous operation in normal process. This idea of this 3P guide, this 3P rule, was done by Professor Leandro et al., a real master Jedi of hazardous area classification. And something very important here is to understand what is fugitive emission. Well, fugitive emission is completely different than leak. We have to understand that. We have a fugitive emission that characterizes the hazardous area classification. It is, for instance, when we see a flange like this. A flange like this, in normal operation, it's an example of hazardous area classification. On the other hand, when we have a leakage, we have a loss of containment. We don't have the control of the process. It's a leakage. I know. In both situations, we have the explosive atmosphere, but however, in different manners. The normal operation, the process under control, it's the hazardous area classification, characterized by the fugitive emissions, like this flange here. When we have a leakage, we have a loss of containment, a loss of control. So we have the same explosive substance. It's true. However, in a different dynamics here, you can't say that it's a hazardous area classification. It's not. A hazardous area classification is just like that, a normal operation with fugitive emissions. Here, you have to have emergency and contingency plan. You have to have emergency contingency action to control that. Here, it's just the normal operation. Also, to understand how this dynamic happens with different substances, we have some codes that characterize the inflammable substance here. it's divided into type, gases and vapors, which is the first code 2. The code 2 plus a letter A, B, or C characterize gases and vapor mixtures. And the code 3 plus A, B, or C characterize dust and fibers. And why that? Because every substance has a different combination of properties. So it makes sense to divide them in groups. However, there is something else. How we can determine the probability of have this fugitive emission in a place? That's the concept of zones. The concepts of zones determines that we have zone 0, zone 1, and zone 2, where zone 0 means something that is continuous, something that always happens. Remember, in normal operation with fugitive emission, we are not talking about here leakage, we are talking about fugitive emissions. Zone 1, where it's likely to have this mixture in the air, and zone 2, where it's not likely to have, and when have will be for a short period of time. Pay attention on that here. Zone 0, 1, and 2, it's on normal operation. We are talking about fugitive emissions. We're not talking about leakage here. And zone 0, 1, and 2 works for gases and vapors, while zone 20, 21, and 22 works for dust and fibers. Okay, but how can we see that happening? Well, a good thing on that is exactly using this tank here to show you how it is zone 0, zone 1, and zone 2. Zone 0 is inside of the tank. It's not the green part. It's exactly from the top of the green part to the top of the tank. That's the area of zone 0. Zone 1, that's the area in the vent where there is the entrance and the exit of the air in the top of the tank, and zone 2 surrounding all this area. That's the hazardous area classification, divided by zone 0, 1, and 2 for gas and vapors, zone 20, 21, and 22 for dust and fiber. And on this concept also, we know that the substances are divided in groups. Group 2 plus A, B, C, depending on the substance for gases and vapors, and group 3 for divided in A, B, C as well for dust and fiber. And as I mentioned in the beginning, that's the first part of 4 classes. In the upcoming classes, we are going to talk about certified equipment, the type of protection, temperature, class and IP protection, equipment protection level, and final remarks. And then we will be 100% able to understand which each of these codes here means. That's our idea in the end of these classes. So I hope that today class help you to start to understand the hazardous area classification and how to beginning the comprehension of the electrical installation in explosive atmosphere, talking about specifically about the group of the substance. Next classes, we are going to understand other parts regarding electrical installation in explosive atmosphere. Thank you very much for today, and we see each other in next class. Hej då!